Welcome to this lesson on ionic bonding. Ionic bonding is one of the fundamental types of chemical bonds that holds matter together. In this lesson, we'll explore how atoms transfer electrons to form strong chemical bonds. Understanding ionic bonding is essential for comprehending how many compounds form and why they have unique properties. Ionic bonding is a chemical bond formed by the complete transfer of electrons from one atom to another. When this transfer occurs, the atoms become charged particles called ions. These ions have opposite charges, which means they attract each other strongly. This electrostatic attraction between oppositely charged ions is what we call an ionic bond. The key word here is complete transfer, meaning electrons don't just share between atoms, they move entirely from one atom to another. For ionic bonding to occur, certain conditions must be met. First, ionic bonds typically form between metals and nonmetals. Second, there must be a large difference in electronegativity between the two atoms. Electronegativity is the ability of an atom to attract electrons. When this difference is large enough, one atom will completely pull electrons away from the other. In this process, the metal loses electrons while the nonmetal gains those electrons. This creates the charged ions that form the ionic bond. The electron transfer process happens in 3 steps. First, the metal atom loses one or more electrons from its outer shell. Second, these electrons undergo a complete movement or transfer through space. Third, the nonmetal atom gains these electrons into its outer shell. This transfer is not a sharing arrangement like in covalent bonding. Instead, it's a complete handoff of electrons from the metal to the nonmetal, resulting in the formation of charged ions. Let's look at the classic example of sodium chloride, commonly known as table salt. Sodium, which is a metal, reacts with chlorine, which is a nonmetal. During this reaction, sodium transfers one electron to chlorine. This creates a positively charged sodium ion and a negatively charged chloride ion. These two oppositely charged ions then attract each other strongly, forming sodium chloride. The chemical formula for this compound is NaCl. Let's examine what happens to each atom individually. Sodium starts with 11 electrons. When it loses one electron, it becomes a sodium ion with a +1 charge. We can write this as sodium atom becomes sodium ion +1 and releases 1 electron. Chlorine, on the other hand, starts with 17 electrons. When it gains 1 electron, it becomes a chloride ion with a -1 charge. We write this as chlorine atom plus 1 electron becomes chloride ion -1. These two processes happen simultaneously during ionic bond formation. Once the ions are formed, something important happens. The positively charged sodium ion and the negatively charged chloride ion experience a strong electrostatic attraction. This is similar to how opposite poles of magnets attract each other. The opposite charges create a powerful electrostatic force that pulls the ions together and holds them in place. This attractive force is what keeps the ionic compound stable and gives it its characteristic properties. The strength of this attraction is what makes ionic bonds so strong. Ionic compounds have several distinctive properties due to their bonding structure. First, they have high melting and boiling points because strong electrostatic forces hold the ions together, requiring lots of energy to break them apart. Second, they form crystalline structures where ions arrange themselves in regular, repeating patterns. Third, ionic compounds conduct electricity when dissolved in water or when melted, because the ions become free to move and carry electric charge. Finally, many ionic compounds are soluble in water, meaning they dissolve easily to form solutions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.